Step-by-step tutorial, how to use PFC Sizing. Welcome to this video tutorial for PFC Sizing, the intelligent tool that makes capacitor bank sizing precise and efficient. PFC Sizing is designed to help companies correct their power factor, optimize energy consumption, and reduce additional costs on their electricity bills. This software allows the user to size a capacitor bank based on the data provided by the client. With PFC Sizing, you will obtain a complete and customized report that includes the capacitor bank design, all the necessary accessories for correct installation, a solution tailored to the specific needs of your electrical system. The operation is very simple. Enter the main data of your electrical system, such as active power, reactive power, and voltage. Select configuration options, such as the number of capacitor bank steps and the nominal voltage of the capacitors. PFC Sizing will automatically perform the calculations and generate a report that includes the ideal capacitor bank for your company. This is the main screen of the calculator. Here, you must enter your credentials. In this case, we already have a user account created, but if you don't have one, you can easily create it. Once the credentials are entered, click the Sign In button. After logging in, you will access the main view of the software, where you will find a drop-down menu labelled Calculations, which allows you to view the list of completed calculations or create a new one. The username area in the upper corner, which includes the logout option. We now go to Create Calculation. By clicking, the software starts with a greeting and asks a few key questions to provide the best options according to your needs. Clicking Next, the first question will be whether you have your company's electricity bill. If the answer is yes, it directs you to a view where the required data from the bill are highlighted, such as billed peak demand power, current power factor, consumption amount. Next, enter the required data. System voltage, which may vary depending on the country. In this example, we'll use 380 volts. Active power in kilowatts, 155. Total bill amount in dollars, $56.98.17. Current power factor, 0.75. And target power factor, 0.95. Finally, select the system frequency, which also depends on the country, and click Calculate. A view will appear showing the demand category and the capacitor bank sizing to be installed. The software automatically generates the capacitor bank result, and you must select the number of steps. If the bank is smaller than 100 kVAR, options from 1 to 6 will be available. If greater, options from 7 to 12 will be available. Next, select the first capacitor value and decide whether it will include a harmonic filter or not. Once configured, press the Generate Report button. The partial report will be available to the user and will show the entered data, the performed calculation, the capacitor bank sizing, technical specifications and technical benefits, such as the transformer power released, and the recommendation to install a monitoring system, such as the CMMS Edge IoT. The full report, available only to the sales team, includes a more detailed introduction, the calculation procedure and formulas used, a single-line diagram of the capacitor bank, technical and economic benefits, and a bill of materials for installation. For sales representatives, the software enables exporting the bill of materials in Excel format, making it easier and faster to prepare quotations. Now, returning to the Start view. What happens if we choose the option indicating we don't have the electricity bill? The software will ask if we want to calculate our capacitor bank. When selecting Yes, a form appears where we must fill in the following data. Power in kilowatts, 250 system voltage, 440 current power factor, 0.56 target power factor, 0.95, and finally, select the system frequency. After performing the calculation, the result indicates that the demand category is high demand. As we can see, the number of enabled steps ranges from 7 to 12. We select 10. For the first capacitor value, we select 7.5. We mark it as with harmonic filter and proceed to advanced mode. Here we can see that in the summation, the 7.5 value is already included. If we select 7.5 again, the total increases to 15 and so on, until reaching the required value, following the rule that values must be multiples, and that from the fourth capacitor onward, the same value is repeated in subsequent steps. If the total value does not reach the required one, the software displays the message, the sum does not satisfy the target value, and allows report generation only once the requirement is met. When generating the partial report, we can see in the executive summary that the values correspond to what we entered, along with capacitor bank sizing, technical specifications, technical benefits of installation, released transformer power, reduced current flow, and the recommendation to monitor the capacitor bank in real time. The full report includes the introduction, executive summary, technical specifications, capacitor bank configuration, and, most importantly, the single-line diagram with the 10 selected steps. It also shows the location of the filters. Later, we'll test one without filters. You can also see the power triangle with its technical benefits and, at the end, the list of materials to be used. For the third path, what happens if we answer no to both the first and second questions on the start screen? This means we already know the reactive power value of our bank and only want to configure the capacitors accurately. We enter 130 as the reactive power, select the system frequency, and this time define the voltage at 400 volts. Next, we select 8 steps with an initial capacitor value of 7.5, and this time we'll do it without a filter. We access advanced mode, reach the acceptable value defined by the software, and proceed to generate the report. We download the partial report, where we can see the entered values, technical specifications, configuration, and capacitor values needed to reach the goal. It also details the technical benefits, such as the difference in the power triangle and the recommendation to monitor the capacitor bank in real time. In the full report, the entered data are displayed again, and in the single-line diagram, we can confirm that no filters were used, as defined in the selection. At the end, you can see the list of materials required for bank installation. Conclusion. With PFC sizing, capacitor bank calculation and sizing are simple, precise, and optimized for each need. Its customization capabilities, combined with automatic report and material list generation, enable efficient and well-informed decision-making. Thank you for following this tutorial. We hope this guide has been helpful and assists you in effectively optimizing your company's power factor.